Welcome to the second part of Chapter 2, which is going to be all about climate change. And so, climate change, which has been in the news a lot lately, especially with the amount of hurricanes that we have been having. Um, what you're seeing here in this picture is some melting permafrost in Alaska. So, we have soil in Alaska that's called permafrost that is typically frozen. And after that permafrost thaws, that a lot of that water thaws and then it leaves that earth to be very, very unstable, and you wind up with scenes like this. Alaska is one of the U.S. states that is really feeling the brunt of climate change with warming temperatures. So we're going to talk about what climate change is and why we should be concerned about it. Um, so climate change is driven by global warming. They're not quite the same thing, but basically our atmosphere is warming, and that is causing climates to change. So some places are going to get hotter. Most places are going to get hotter, but it's going to change precipitation patterns. And so again, we want to remember that difference between climate and weather. Just because one weather event does not prove or disprove climate change, we're looking at kind of aggregate numbers, averaging together like how frequent do we usually have hurricanes? How severe are they? And look at how that is changing. So the entire planet is getting hotter over time, and other aspects of climate are changing as a result. So we know this by three very kind of simple observations. The science behind climate change is pretty simple. What gets a little more difficult is projecting exactly how climates are going to change just because of there's so many variables involved. Um, but these three kind of simple observations, right? One, greenhouse gases absorb infrared. This we know, this is well proven. So we have greenhouse gases in our atmosphere which provide us with this natural greenhouse effect, things like CO2 and methane. And so when the sun shines, solar radiation comes in to our planet, is re-radiated by the planet as infrared heat. And some of that is trapped by our atmosphere, and that makes the world like a nice, comfortable place to live. But more heat is escaping into space. And so what we have now is we are adding lots of greenhouse gases to the atmosphere. And so that solar radiation is coming in. We are again re-radiating it, but more of that emitted heat is being trapped in the atmosphere and less heat is escaping into space. So observation number two is there are more greenhouse gases in the atmosphere now than before, right? So we know that they absorb infrared and we know that there are more of them. We can take measurements of atmospheric gases, like we know that they're there. So that is really not up for dispute either. And observation three is that the planet is heating up. And so every year in the past couple of years has been the hottest year on record. 2016 now was the hottest year on record. So due to these three observations, we are adding more greenhouse gases to the atmosphere. Greenhouse gases absorb infrared heat, and we're watching the planet heating up. We can tell that we are causing this warming of the planet and climates to change. And the science is really strong on this. This is from a few years ago, but a little pie chart looking at nearly 14,000 peer-reviewed climate articles. Only 24 reject global warming, which is like a very kind of small non-percentage. There is scientific consensus around the fact that climate change is happening. One thing that you might hear is like, oh, well, people aren't sure and there's not scientific consensus. There absolutely is scientific consensus. And believe you me, scientists love to disagree with each other. So if they had reason to, they would. So we have two main sources of these greenhouse gases that we are adding to the atmosphere. The first and the one you probably hear most about is carbon dioxide, which is released anytime we burn anything with carbon in it. So all fossil fuels, coal from power plants contributes some of the most greenhouse gases. Natural gas also contributes greenhouse gases but about half as much as coal does. Deforestation, when we have a bunch of carbon that is stored in forests and we remove those trees, we are releasing carbon back into the atmosphere. And then methane, which comes from decomposing plant matter and is primarily from livestock, gas, and droppings. We have more cattle on this planet than ever before. Eating meat used to be kind of a luxury that you might do once a week, and there are plenty of people in the US who eat meat 3 times a day for every meal. And as countries get a higher level of affluence and kind of a larger middle class, one of the things that they tend to do is start eating more meat. And so having all of this livestock on this planet is really having an effect on climate change. And the other source of methane is that melting permafrost that I showed you in that first picture of this second part of the lecture. And there's also methane in that permafrost. When it melts, that methane is released, and it's this feedback loop because as that permafrost melts, it releases methane. Methane causes more warming, more permafrost is melting. And so we can take and have taken measurements of carbon dioxide. This is from one station in Hawaii. And so we can watch from 1955. This graph goes to 2005, has certainly continued to go up. This graph is just a little bit old, but we can see rising CO2 levels in the atmosphere. And so when we think about global warming trends, there are 3 graphs here. The first one is millions of years, and certainly over millions of years, our climate has changed many times. We're going to talk about how we know that, but we have had a very varied climate. This one here is thousands of years, which I'll talk about in a second. This one here is in the past 1,000 years, and what we can see is after we hit the Industrial Revolution and we started burning lots of fossil fuels, we are having this increase in temperature that keeps going up. So here is our big concern, is the short-term change in climate that is happening very rapidly, much more rapidly than it has in the past. But also our concern, and you're going to watch a video about this afterwards, is that really our climate stabilized in the past 10,000 years. Over the previous thousands of years, human beings were around, but we did have a very kind of varied climate, and then the Earth kind of regulated itself and stabilized. And it was during that past 10,000 years that we figured out settlement and agriculture and all this other stuff. So it's really us who are going to have a problem with this changing climate. So again, it's about a short-term warming trend. We were steady for about 10,000 years, and the 14 hottest years in human history have all occurred since 1998. And this slide, I apologize, I forgot to update it. It should say 2016 is the hottest year on record. It used to say 2014, and then it said 2015, and now it says 2016. And so these are beyond natural fluctuations, this level of warming in this short of a period of time. And scientists have been saying for quite a few years that we were very worried about warming, that we could see this trend happening, and now all of that is kind of coming to fruition. And so again, just because it's cold in one place doesn't mean the planet isn't heating. So here's looking at above and below normal average temperature. And so by far more of the planet is experiencing above normal temperature than below normal temperature. And so how do we know that this is happening? How do we understand long-term climate? The first way we understand is simply with thermometers, which we have measurements for about the last 120 years only, but we can see very discrete rises in temperature. Then we use something else called dendrochronology, which is very, very accurate, which uses tree rings to look back hundreds of years. And so they can, dendrochronologists can tell by the width and characteristics of a tree ring what the temperatures were like that year and what the precipitation was like. It's incredibly accurate. It's amazing. Um, and then we use something called oxygen isotope analysis. We look at ice core samples and coral reefs, and we can look thousands of years back with that and tell something about temperature and about greenhouse gas levels. And last, to go millions years back, we look at something called fossilized pollen analysis. where based upon the characteristics of fossilized pollen that we can date, we can understand things about the climate. So we have a really good understanding of our long-term climate on this planet. And so one of our concerns with climate change is rising sea levels. As temperatures rise, more ice melts, there's more liquid in the ocean. We see surface melting in Greenland on the top there. Um, but actually, one of the bigger threats of sea level rise is not just that ice melting, but sea level is also rising from something called thermal expansion. And so, as things heat up, they expand, and that includes the ocean. The ocean covers such a significant portion of our planet, and as it warms up, it begins to expand, and that could say a lot about our sea level rise. And so, this is kind of an artist rendition of what San Diego would look like if you've spent time in San Diego, if the ice caps melted. So good portions of the city would be completely gone, and we'd wind up with this huge inland estuary. So the issue is global, right? It's not a local issue, although we are feeling local effects, and there are certainly local initiatives to deal with climate change. But we're affecting global climates, and again, which is those average conditions. So we have increased temperature, which increases evaporation over our oceans. And so we're going to get more precipitation. Some places are going to get a lot more, which will result in flooding. Some precipitation patterns are going to shift and can result in drought. And one of the things with that increased evaporation, that warmer water, storms such as hurricanes and typhoons are going to get much stronger and more frequent. Um, so in some places, again, we're going to get those stronger tropical cyclones like hurricanes and typhoons. We also could get more snowfall in some places. Some places, though, will get drier because some of that precipitation is going to shift away. And again, in the past 10,000 years, we have settled in places largely based upon climate. And so if that climate changes, our water availability could change, which could present a lot of problems. And subsequently, temperature patterns change, pressures changes, winds change, and it's hard to model exactly how all of these will change. And their effects on wildlife, ocean ecosystems, and especially agriculture. Um, you are going to have large effects on agriculture if you get too much rain or not enough rain. And there are more feedback loops like that one with methane that we might not fully understand yet, which is why it's hard to definitively say exactly what's going to happen in certain areas from climate change, other than the fact that they are going to change. So the wet is going to get wetter, and the dry is going to get drier, but it's going to be wet overall. This is scenes from 2014, where in Washington State you were getting more rain, and you were getting uh, things like landslides. And then the bottom here is from the height of our drought that we have recently been pulled out of, which it looks like this year we're also going to get a decent amount of rain, but kind of these longer, more severe droughts. You can see what Folsom Lake in California looked like at the height of that drought. And so again, it's happening. It's super controversial. It shouldn't be. I can attest that there is no global climate change conspiracy. It is actually happening. You're going to watch some short videos about it, and then you're going to complete the exercises for this chapter, and that will be on your country journal, and that will be the end of this module.